Hello, good morning. Myself Atul Kalai. Today I am going to explain the first chapter of nuclear chemistry, that is nuclear fission. First of all, we have to know about basic things. That is first things is radioactivity. What is meant by radioactivity? An element is said to be radioactive if the nuclei of its atom keep disintegrating spontaneously. ओके म्हणजे एखाद्या एलिमेंटचा न्यूक्लियर जो असतो तो काय होणार कंटिन्युअसली काय होणार आहे स्पॉन्टेनियसली काय होणार आहे डिसइंटिग्रेट होणार आहे ओके ट्रान्सफॉर्मिंग देअर बाय इनटू अ डिफरंट एलिमेंट आणि त्याचं रूपांतर एक कशात होणार आहे दुसऱ्या एलिमेंट्स होणार आहे बाय इमिटिंग इन द प्रोसेस न्यूक्लियर पार्टिकल्स अँड रेडिएशन आणि या प्रोसेसमध्ये काय होणार आहे न्यूक्लियर पार्टिकल्स किंवा रेडिएशन्स काय होतात इमिट होतात रेडिओ ॲक्टिव्हिटी हा एलिमेंट काय आहे रेडिओ ॲक्टिव्ह असला म्हणजे काय असणार आहे त्याच्यामध्ये कंटिन्युअस काय होणार आहे डिसइंटिग्रेशन होणार आहे रेडिओ ॲक्टिव्ह म्हणजे हा काय असतो अनस्टेबल असतो अनस्टेबलचं कशात रूपांतर होणार आहे स्टेबलमध्ये होणार आहे कसं होणार आहे बाय डिसइंटिग्रेशन बाय इमिशन ऑफ radiation. That's why it is called as a radioactive substance. Okay, this is the basic concept of nuclear fission, that is the radioactivity. Then what is meant by nuclear fission? Nuclear fission म्हणजे काय? It is the process in which the nucleus is excited by neutron or by other means and thus breaks up into two fragments of comparable size. न्यूक्लिअर फिशन म्हणजे काय ज्या प्रोसेसमध्ये काय होणार आहे हा जो एलिमेंट आहे सपोज वी टेक ॲन एक्झाम्पल ऑफ युरेनियम एलिमेंट इट टेक्स न्यूट्रॉन हा काय घेतो न्यूट्रॉन घेतो ओके अँड इट गोईंग्स टू द एक्सायटेड स्टेट ओके म्हणजे न्यूट्रॉन घेतल्यानंतर न्यूट्रॉन याच्यावरती काय होतं बंबार्ड झाल्यामुळे काय होणार याची एनर्जी वाढून जाते मीन्स इट टेक्स एनर्जी फ्रॉम neutron and it goes to the excited state and after that it is observed that it breaks up into two comparable fragments means which are nearly equal in size break up okay and it emits some neutrons are emitted okay means the uranium bombarded with neutron it goes to the excited state and it breaks up into two fragments and this process is known as nuclear fission. It is the process in which the nucleus is excited by neutron and breaks up into two comparable fragments okay which having comparable size. It is called as a nuclear fission. The discovery of nuclear fission. Neutrons are discovered by James Chadwick in 1932. These are the some basic points you have to remember that neutrons are discovered by James Chadwick in 1932 and you know already the uranium is the heaviest elements found in the nature okay uranium is the heaviest element and previously we seen that it is an radioactive elements and radioactive elements असला म्हणजे तो काय असतो इट इमिट्स कंटिन्यू रॅडिएशन काय करतो तो इमिट्स करतो द डिस्कवरी इज द क्युमिनेशन ऑफ रिझल्ट ऑफ थ्री ग्रुप ऑफ वर्कर्स okay these are the three groups of worker who work in the discovery of nuclear fission. First one is the Enrico Fermi in Italy. Second group is the Juliette Curie and Savage in France. And third group is Otto Hahn and Strassmann in Germany. These are the three groups of workers. Then first group is Fermi's experiment. We called it as a Fermi's experiment, who work in the period of 1934 to 1938. Then what is his work? Uranium compound bombarded with slow neutron hoping to produce transuranic elements. Okay, means transuranic elements means those having atomic number greater than 92 or after the uranium Okay, these are called as a transuranic elements. Transuranic elements means those having atomic number greater than 92. Okay, the capture of neutron by uranium would leads to a neutron rich isotope. सुरुवातीला काय घेतला युरेनियम घेतला 92 288 हा काय असतो ॲटॉमिक नंबर 288 काय असतो मास नंबर ओके इट कॅप्चर्स द न्यूट्रॉन कॅप्चर केला म्हणजे इट गोइंग्स टू द excited state or which is called as the neutron rich isotope. Here is a 289. Okay, 288 289. Okay, neutron rich isotope which by beta decay would result in element having atomic number is 93. Okay, means first of all it absorbs or it bombarded with neutron, it goes to the excited state which forms a neutron rich isotope, and then after beta decays the elements produced having atomic number 93. Here is a 92, here is a 93, means here is the formation of transuranic elements is takes place. Okay, and by successive neutron capture and beta decay other transuranic elements as 94 95 etc would result. And here is observed that here is 92 after absorption, 92 to 88 after bombardment of neutron it goes to excited state which produce a neutron rich species means which gives a 289. Then by emission of beta decay it gives Z having greater one unit higher atomic number. Okay, means here is 92, it gives 93. Same procedure which if we carried out, then it is observed that the atomic number goes on increases, means formation of transuranic element would results. Okay, but on analysis of analysis of the product uranium plus neutron interaction found to be several activities than transuranic element. Okay, means in this case it is observed as formation of transuranic element is takes place. Okay, this is the result of Fermi's experiment. Then second group, that is a Joliet and Savage experiment, who carried out the work in the same period, that is 1934 to 1938. The same phenomena, uranium plus neutron interaction, investigated by Joliet, Curie and Savage, reported a strange result. त्यांनी काय केलं सेम प्रकारचा इंटरॅक्शन त्यांनी घडून आणली, दॅट इज युरेनियम प्लस न्यूट्रॉन इंटरॅक्शन, अँड देन इट इज ऑब्झर्व दॅट द strange result is observed. The resulting element seemed to be closer to that of lanthanum. ओके, मग त्यांना काय दिसलं एक काही एलिमेंट जे असे दिसले की त्यांचा ॲटॉमिक नंबर काय होता क्लोजर टू लॅन्थॅनियम. ओके, दॅट इज 57 विच इज फार अवे दॅन एक्सपेक्टेशन. आपण काय जनरली काय एक्सपेक्ट केलं होतं की ट्रान्सयुरॅनिक एलिमेंट पहिल्या एक्सपेरिमेंटमध्ये त्यांनी काय ऑब्झर्व केलं की ट्रान्सयुरॅनिक एलिमेंट्स तयार झाला. बट इन दिस केस इट इज ऑब्झर्व दॅट द रिझल्टिंग एलिमेंट सीम टू बी क्लोजर टू दॅट लॅन्थॅनम. Okay, same experiment is carried out, that is uranium 92 to 35 which bombarded with neutron, it goes to the excited state, then it gives three products, that is ABC, but one of these have activity closer to lanthanum. आणि यांच्यामधला जो एखादा एलिमेंट असेल जो तयार झालेला आहे त्याची काय ॲक्टिव्हिटी काय होती which is closer to that of lanthanum which having atomic number 57. Means here is the strange result is observed by the experiment done by Joliet and Savage experiment. Okay, and third group, that is the Hahn and Trasmer experiment, who also doing in the same period, that is 1934 to 1938. Okay, he also done same investigation, uranium plus neutron interaction was carried out by them and confirmed that one of the element is very similar to barium. Means here is also different result is observed. That is, one of the element of the result is very similar to the barium rather than promethium. Hand and Transman declare that one of the product of uranium plus neutron interaction was barium. Okay, he's also done same experiment, that is 92 to 38, which bombarded with neutron. It goes to the excited state, but it is observed that the product are different. One of the product is barium and one product is krypton. Then, as per the definition of nuclear fission, the bombardment of neutron with uranium, it goes to the excited state and it gives two fragments which having a comparable size. And दोघांची साइज काय असणार आहे, comparable आहे size आहे. Okay, here is also same observation is observed, that is one of the element is a barium and another is a krypton. This was the discovery of nuclear fission interaction. मग या पद्धतीने न्यूक्लिअर फिशनचं काय असणार झाले, डिस्कवरी झालेली आहे. ओके, द splitting of uranium into two fragments, that is one is the Z is equal 56 and another is a 36. For this is the discovery of nuclear fission. For this discovery, Hahn won the Nobel Prize in 1944. Hahn won the Nobel Prize in 1944. Okay. In the Fermi's experiment, it is observed that formation of transuranic elements takes place. That is the bombardment of 92 to 38 by neutron. It gives uranium 239, which is in an excited state. By emission of beta radiation, it gives the transuranic elements, means having the atomic number greater than 93. Same reaction is carried out, then it is observed that the transuranic elements are formed. Okay, but in the case of Joliet and Savage experiment, the strange result is observed. That is, the same experiment is carried out, that is the uranium 92 to 38, it goes to the excited state, and then it is observed that one of the element, the resulting element, seem to be closer than to that of lanthanum. म्हणजे यांच्यापैकी एखादा एलिमेंट असा असेल, वन ऑफ दिस हॅव ॲक्टिव्हिटी क्लोजर टू द lanthanum. Okay, means strange result is observed. And then last one, the Hahn and Trussman doing same experiment, and they confirm that one of the element is similar to the barium. Same experiment is carried out by bombardment of neutron. It goes to the excited state, and it is observed that one of the element is barium. Okay, means according to the definition, the fragmentation takes place, and this is a discovery of nuclear fission. For this discovery, Hahn won Nobel Prize in 1944. Thank you.